Oh, hi everyone. We're getting nested me's, you see? So many me's are in here. Um, and we're going to move away from that me to a future version of me that's had lots more math practice. And we're going to do that with questions 26 through 36. We did an extra question last video, so if you missed looking for question 25, check the end of the previous video. Okay, let's take a look. Which pair of equations best matches the lines shown on the graph? One thing I notice is that these lines look parallel. This one, line 2 has an intercept of -4, and line 1 has an intercept of, that's the point 0.05, and this is the point 0, -4. Okay, so those are going to be b values. I'm looking for b values of 5 and -4, and I want the slopes to be the same because these lines look parallel. Okay, line y is equal to, and both of them have negative slopes. There they are, right at the bottom there. Okay, see, both of them have negative slopes, and there's my +5 and my -4, so that's correct.
Yes, I pointed in your arrow.
Now, here's some values for a table for a linear relation. Which of the following represents the relationship shown in the table of values? Okay, again, you can work with any 2 points. I'm going to work with the last two because they happen to have the smallest, most manageable numbers. First, I calculate my m. And in this case, it's change in y. So this is grow by 12. And then over change in x. This is grow by 9. All right? So m is equal to 12 over 9, which is a fancy way of saying 4/3. And then to find b, while you say y is equal to 4/3, you just put in your m, multiply by x, plus some value b. Okay? And then substitute one of these points in for b. We're going to choose the positive point. We could choose any of them. They all work. So when y is 3, we have 4 over 3 multiplied by x is 12, plus some value b that makes it true. 4/3 of 12 is 16. Because a third of 12 is 4, and 4 times 4 is 16. So 3 is equal to 16 plus b. And if you're not sure, 4 over 3 times 12. You could do this as 12 over 1, and then you'd get 48 divided by 3, and then you reduce that fraction, you find it's 16. Okay? Or you do it the way I do it. 4 over 3 times 12 can be written as 3 times 4. 3 cancels 3, and then so this is equal to 4 times 4, which is 16. Okay? It doesn't matter how you do it, just get 16. Okay? 3 is equal to 16 plus b, so then I subtract 16 from both sides to get -13 equals b. Okay? There it is. Keep going. Okay, 28. So over here, PQ and RS are parallel line segments. What's the value of y? Okay, where's y? There's y right there. All right, so we need to find what that is. Okay, so if they're parallel, then I know their slopes are the same. That's the definition for parallel lines. Parallel lines have the same slope. Okay, so in that case, this one goes from 6 to 9. That's plus 3 of run, because that's change in x. And then it rises 10. So that's plus 10 in y. All right? This one also has a run of 3 and should therefore have a rise of 10. So if we rise 10 from -2, y would be 8. 29. PQ is a line segment with a slope 3 over 7, shown below. The point R is plotted so that RQ is perpendicular to PQ. Oh, okay, cool. So R is like over here somewhere, perpendicular. Which of the following could be point R? Okay, so here's the thing with perpendicular slopes. If I have this line here, and let's say it has a slope of 2/3. And I want a line that's going to be perpendicular to that. I'll draw it in purple to delight the senses. Trust me, that's perpendicular. Okay, makes a 90-degree angle. Its slope will be the flopposite. I make the opposite sign and I flop the fraction. -3/2. Okay? And so this is the relationship for negative slopes. Sorry, for perpendicular lines. So what I want is a line with slope. I'm told the slope up here, 3/7. Okay. So what does that mean? It means I run 7 when I rise 3. All right. So instead of that, let's rise 7 and run -3. Okay. Because here the slope is 3/7. So let me just give myself some space here. Okay, if I have 3/7 is equal to m, then -1/m, meaning I flip the fraction and then multiply it by -1, should be -7/3. So let's go -7, or let's go, but I could also say that this is 7/3. That's the one I want to use. So I'm going to go up 7. So I go up to 5, and then back 3.
Oh, it's a really big circle.
So there, the 0.15. There, the 0.15 could be on that line. And then look, if I draw a line segment there, that will be a square corner. And what is this up here? This is point R. This could be the point R right there. Again, I just used the opposite slope to get back there. Okay, that was not hard. Donna has correctly drawn a line on the XY plane. Good job, Donna. Okay, my line is parallel to the line y is equal to -x plus 1, and has the same y-intercept as the y equals -3. So it's parallel to this slope, and it has the same y-intercept there. So her line is y is equal to -x plus 6.
What are you trying to draw?
Keep going. The following graph shows the quadrilateral ABCD. Delightful. Which of the following statements is false? AD is parallel to BC. Well, let's check it. AD has a slope of 1. BC has a slope of 1. How do I know these have slopes of 1? Run 3, rise 3. Run 2, rise 3. Okay. DC is parallel to AB. Well, that's false. Visually, you can sort of tell that it's narrower here than it is here. It's farther apart there than there. Okay. If you check, this one has a slope -1. It rises -10 and runs 10. So that's a slope -1. This rises from 12 down to 3. So it rises -9 and runs 10. This is -9, 10. So that's not -1. It's slightly smaller than -1. Yeah, so it's a smaller slope. Okay, so that's why that is that. Okay, what is the equation of the line that passes through the point 2 and is parallel to this line? Okay, if it's parallel to that line, then its slope is equal to -3. So, we know its slope, so we know y is equal to -3x plus some value b. And now we're going to input this point to find b. When y is 0, x is 2. So -3 times 2 plus b. 0 equals -6 plus some number b. And then that would tell us that b is equal to 6. Okay, so it would be this line. B is 6, and M is the same as this parallel line. Let's keep going, see if we can finish this video before my computer dies. The line has the following characteristics. It's perpendicular to this line, so I know if its M is -2, because I flip this fraction and flip the sign to find the perpendicular line. And it passes through this point. Okay? So now I know y is equal to -2x plus b. Input this point. When at y is 0, x is 4. -2 times 4 plus b. b is equal to 8. Verify it with your own algebra. So this one here. Consider these 5 points. Which line segment is parallel to AB? Okay, so we have to find one that has the same slope. So here, let's take a look at it. AB, so here's A, 1, 4. And then here is B, 6, 3. So this is decrease by 1. That's my rise. This is increase by 5. Okay, so M, we're looking for another line segment that has a slope -1/5. So what else does that? Here's -1/5, but that may not necessarily do it. If I go here, D and E look good. Watch this. X increases by 5, Y decreases by 1. So DE is the answer. You just have to look and hunt. But you have to know what you're looking for. If they're parallel, then they have the same slope. So I had to find the slope here of the given line. And once I had that slope, I just looked for two other points that would produce the same slope. You can verify for yourself that that's true. Okay, what are the coordinates of the point of intersection of the lines y is equal to -x plus 1? Here's the line -x plus 1. Mr. Jennings, how did you graph that so fast? Well, I do 1 is the B, and then I go over 1, down 1. Okay, let's zoom in so you can see more clearly. Over 1, down 1, and then the line x is equal to 3. X is equal to 3 is a vertical line, goes up here and down here. And there's the intersection, the point 3, -2. Okay, and last question. The equations y is equal to -x minus 5 and y is equal to 3 represent straight lines that intersect in which quadrant? Okay. Which quadrant do they intersect? Well, helps to visualize your lines and then graph them. I happen to know this is going to be in the second quadrant, and I'll show you why. Here is -1, 2, 3, 4, 5, -5, and y is equal to -x. So this would be a point on that line. This would be a point on that line. This is a point on that line. And this is a point on that line. Ooh, we just hit the point, the line y is equal to 3. That's the line y is equal to 3. And this is their intersection in the second quadrant. Dun, 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 dun. That's it. So, any questions about this stuff? Absolutely hit me up by email. I hope your math practice is fruitful, and have a great day, everyone. Bye for now.